Hello, everyone, and welcome. My name is Sam Biddlecom. I am the Motion Product Specialist here at EandM, and today I am switching gears from recent videos I've made highlighting the Siemens motion control portfolio and moving over to our other supplier of motion control technologies, Festo, specifically configuring an electro servo system using Festo's electric motion sizing or EMS configurator found right here on the main website for Festo. Now, before we hop into the configuration, there are some questions you need answered beforehand. Not just for Festo, but any servo solution you may think of configuring yourself, as can be seen right here on the right-hand side of the screen. Starting with number one, we have stroke/distance. Now, this is the total distance we are hoping to move our slide or carriage on the actuator we'll be sizing. Next, we have mounting position, which is in relation to the actuator orientation, aka horizontal or vertical, as we will see later on in the configuring. Third is our cycle times/speeds. So how fast we want this to move, how long do we want this to take to move to the required distance we commanded to, essentially a key factor of our motion profile definition. The other factor being our stroke length, question number one. Moving on to number four, we have our payload. This is how heavy our object we are planning to move is, followed by the position of said payload on the slide/carriage. This is represented as center of gravity of mass and center of force, configurable options in the EMS. Now moving on to number six, we get to more general questions for sizing a drive. So we have our supply voltage information. So what's the voltage range? Is it single or three-phase in nature, 50, 60 hertz? Kind of just defining that. Moving on to number seven, we have our field bus communication options to choose from. How are we communicating with the motor and the drive? Our cable lengths for both power and feedback devices. The feedback device in question, aka your encoder. What type are we using? What resolution do you require? Single or multi-turn, incremental or absolute? And number 10, for the mounting of our motor to the actuator, is it going to be an axial, which is a direct connection of the motor to the actuator, or a form factor friendly way with a parallel kit, which in Festo's world utilizes a one-to-one tooth belt connection between the motor spindle and actuator spindle. Once you have these questions answered, you're pretty much fully ready to size your servo system. So to get to the EMS tool, we'd start on our Festo website, go to automation in the top left, and single left click on engineering tools. This will bring up many options for configuring both the electric and pneumatic portfolios of Festo, but for today, we're going to find electric motion sizing right here and single click. This will open up a second tab, perfectly okay, and we'll be asked, what kind of movement do you need a solution for? It breaks this into linear and rotary movement and multi-axis handling applications for things like Cartesian robots for your 2D or 3D handling application. However, if we went with our third option, this would bring us to the Handling Guide Online, or HGO, which we will be covering most likely in a future video. For today, though, I'm going to keep it simple and imagine we're just using a standard linear actuator, so I will be expanding linear movement. Once we expand, we're given a few example options for a solution in the application we're dealing with, such as pressing applications, some sort of cantilever actuator as a z-axis, our simplified motion series SMS, as well as options for Festo motors to be coupled to third-party applications like third-party ball screw actuators, conveyors, or rack and pinion mechanisms. For today, though, and usually when I go to size a linear actuator, I choose the linear load case in the top left first option. Once we click on that, we're brought to our main configuring page. Something I want to point out before we get started with this, of course, is right here in the bottom of the page, we have 20,694 possible combinations of solutions for the default settings that are entered in to the system. This number will update live in real time with every change we make, either increasing or decreasing depending on the options we are choosing and speccing out for our solution. So without further ado, we'll hop right into the configuration. Starting with our field bus/control, we have Ethernet IP, but we also have the following options like digital I/O, EtherCAT, PROFINET, which we will choose, Modbus TCP, CAN open, and DeviceNet. I choose PROFINET for a reason we will be seeing at the end of the video. Once we click on this, it will update in real time. As you can see, there is no change in the number of possible solutions, since Ethernet IP and PROFINET are both Ethernet-based field bus protocols. Moving on to our actuator type, we have linear actuator selected, which is perfectly okay. This is what we wanted, but by clicking down, we can also reveal other options. For fun, I'm just going to click on mini slide and apply the change, and we'll see a load symbol appear on the bottom, and immediately we see that we've hopped up about 3,000 possible combinations for our application just by adding that mini slide. Moving over to mounting position, it's at 0 degrees already. If you don't understand what that means, and for Festo, we can click on the little informational button and it tells us that 0 degrees means a horizontal axis linear actuator, where 90 degrees and negative 90 degrees represent a vertical standing actuator with the slide starting either at the bottom or the top respectively for the options. For today, I'm going to imagine we're just doing a perfectly level horizontal linear actuator, so I'm going to keep that at 0. Moving on now, we have the motion cycle. This is basically our motion profile we had discussed earlier in the question. So this is our cycle times and speeds would come into play and our stroke distance. So in this case, the default we're given is the first movement step is moving from our home position to 200 millimeters carrying a 1 kilogram payload. No external forces and no speeds defined right now, but essentially traveling over 10 seconds with a 0.2 second pause time between the steps where it then returns back to home, no change in payload. Our external forces can be positive or negative in nature, negative being signs of decelerating such as friction or pressing, and we can change these as we need. For today though, I'm just going to keep this at the default options, but you can change this depending on what your payload is, how far in the target position and distance you want to move the actuator, and just going in line with the questions we had gone over previously. As you can see though, we are still at over 23,000 possible combinations. For our advanced filters next, we'll show how we can narrow that number down even more so. So as we expand our advanced filters, we will then see options to further configure and elaborate on our servo drive, motor, and actuator information we have collected. Starting on the left, we'll go down and answer servo drive. So here we can choose from either a DC or single or three-phase AC supply voltage source. For this, I'm just going to stick with a very common 480 three-phase, something I see a lot when I configure items, and select no selection for anything else. If you choose options fast enough too, you can kind of avoid or get a bunch of things updated at the same time to avoid this little loading screen. I wasn't quick enough, of course, so this is loading, but as we see, this change, it should now drop significantly. We just took off 10,000 possible combinations just by focusing on a 483 phase input voltage. Moving down now, we have our mass moment of inertia options. We can choose and click on this to read more about the information as follows. I'm going to keep that defaulted though at medium for now, unless otherwise specified by our customer or by the system you have. We then have our acceleration behavior or jerk. I will leave this defaulted at medium. And then down here, it suggests the potential servo drive families we have options to choose from. Right now it shows CMMT-AS for the servo drive family. CMMT-ST was an option, but now grayed out based upon the application and options we chose above. And when we drop down the menu, we also have available to us CMMP-AS as well. I'm just going to keep CMMT-AS for today's trial. Moving on then to our motor, back to the top, we can choose what sort of gearbox you want attached to this. I'm going to actually unselect no gearbox just to show the full range of options that get added to our system. We have a little bit of an update going on right down here. So now we're actually down to 10,478 possible combinations. We have the following gear ratios available. You can either hit the X here to take one away or drop down the menu when unselected, whatever works best. I'll just exit out that, take out the 20-to-1 option, let that update, and then move on to our motor technologies. Here, we are clearly selecting a servo motor for our system. Stepper motors for Festo are DC range, and we usually see stepper motors in the DC voltage range. So by Xing out no selection on DC voltage in the servo drive, stepper motor was never going to be an option moving forward. But that can be easily changed by enabling 24 or 48 volts respectively. Same with our EC motor. Moving on, then we have our encoder. We can go with a Festo recommendation based upon other options we put into the configurator, or choose the one we want to use, such as incremental, absolute, single, or multi-turn options, or no encoder period. But for now, I will go with our Festo recommendation. Same with our motor brake. We can choose if we want with or without a holding brake. We then have our motor attachment position. This is where you choose the number 10 option, whether we want an axial or parallel kit mounting option. I'm going to keep it axial for now. Moving on then, and once again, like the servo drive family, it then narrows down the motor family that best suits the application needs and requirements I have set beforehand. We have a bunch of options that were available at first, but then got grayed out based off of our options, so we are left with EMMT-AS. Same with our sizes. The following grayed out were sizes that are not going to be applicable based off our previous options, and the ones available giving us the full range. I won't exit out this time just to keep our possible solutions wide open. We then have ambient temperature and cable lengths as well. I'll keep those defaulted for now, but feel free to change those to best fit your needs. Moving on then finally to our actuator, we have the actuator technologies to choose from. So we have the tooth belt or ball screw actuators from Festo's site. I'll keep both those open. I want to see both options. Guide type for the information. This kind of shows you the Festo recommendation, recirculating ball bearings, ball bearing cage guide. We can choose from the options here, or we can let Festo once again recommend the best possible solution. So I will keep our Festo recommendation for today's configuration. Moving on, then we have calculate guide load. I always click yes on this. Let it calculate those things out for me. If we click no, it would ask us then the center of force options for payload. This kind of goes back to position of payload question I spoke about before. So to calculate this out, I'm going to just have it calculated for us and click on yes. Next, we have the mounting orientation of the slider itself. So we had how we want to mount this, either vertical or horizontal, but now we have how we want to mount the carriage slash slider. Do we want it on the upside or down or bottom side of the actuator, or on the side? I'm going to choose slider up slash down for our positioning. We then have more information here on the position of the payload or center of gravity of mass. Well, that's weird. There we go. I don't know why that was selected, but it kind of shows just the various center of gravities for each of the items, just to give you a little bit of details about what that means. I'm going to leave this at 0, 0, 0, same with our center of force. Imagine this is the perfect payload that we are carrying. Going down then, we have our actuator design. This is either a standard or already for food industry configuration type for the actuator we're choosing. I'll click standard for today. Same with our slide. We have a standard or protected slide. The protected slide has coverings for the guide rail, so it can protect against any sort of airborne pollutants or contaminants that might get in the rail guideline and mess with the actual movement of your carriage and just add a bunch of unnecessary contaminants and dirtiness to it. So you can do protected, but I'm going to keep this standard for today. Next, then we have a repetition accuracy. So we have a standard repetition of plus or minus 0.1 millimeter tolerance and higher, and then a precise at 0.02 millimeters plus or minus. Once again, we have summarized the actuator families we have to our disposal based upon our selections. We have quite a bit of the actuator families to choose from, as well as actuator sizes. For our actuator stroke as well, we have this kind of talks about a user-defined minimum actuator stroke for the selected product. So if we did a user-defined, we could choose what our user-defined minimum actuator stroke actually is. Once again, though, I will go with Festo recommendation for this. And for actuator support spacing, if you do need any support spacing, you can enter your millimeters into here. But essentially after this, you would be done with your configuration. As we see, we went from 23,000 plus possible combinations back down to 8,000. That's still quite a bit, but don't worry. Once we hit continue, as such, it'll start to load and calculate, and will spit out in order the best, most economical solutions for us, and then give us variations upon that. Usually one or 5 on the first page, as can be seen here. and even a sixth. These are all the top possible solutions, mix and matching based upon our selections. So for today, I'm just going to look at our most economic solution, solution number 1. It first gives us an overview of the system. As we can see here, this gives us the calculated mass moment of inertia, our total cycle time, 0.77 seconds, supply voltage, our gear ratio, it's giving us a 3-to-1 gearbox. Then it gives the full servo drive, servo motor, and it gives us a tooth belt linear actuator with the part numbers seen here. We then have current options and some technical information that can be seen. It gives us our servo drive, motor, actuator, and guide workloads as seen here, as well as below some of additional parts that will be added to our bill of materials or BOM, like a gearbox, our motor mounting kit, and our motor cable itself. Going over to the next tab, we get into more of the specifics of the motion profile results. So here's our full motion profile graph here that you can kind of run through and see the values change as we are doing our movements. And then it gives more information on the actual max speeds, accelerations, our motor torques, max current, max power, and just the technical information you would want to see and compare to maybe something you've calculated out or what you need to hit based off of your application. Same with our motor characteristics chart here, same deal. You can kind of move through, see where we are operating at, and see the torque steps for each of the movements in our motion profile we had defined earlier. Next, then we have our bill of materials. This shows all the items for our full servo solution. So we have our tooth bolt actus, servo motor, the gearbox for our servo motor, the motor mounting kit, the axial motor mounting kit to our tooth belt axis actuator, the motor cable, and our servo drive. And then it just gives us a little more information, like calculated guide workload is valid for an actuator, supports spacing of 200 millimeters. It's pretty good, and if that's good for you, that's awesome. And then finally, the reason why I chose PROFINET in the beginning, this tab shows our PLC connectivity. So from here, we can select our PLC, which could be a Siemens PLC in this case, since Siemens communicates natively with PROFINET. And here we can then have a PROFINET connection to our Siemens TAA portal and our servo drive. And with the details here, we have various links to application notes for the servo drive itself and how that can work with specific PLC telegrams and safety telegrams, the PLC S7-1500 by PROFINET, some commissioning guidelines here and plugins, as well as a GSDML file that you can download and then upload into your TAA portal project to bring up this servo drive itself, as well as function blocks from Siemens to be able to be used with your servo drive. If this solution is what you want, then you can easily download this and add this to your basket and to your cart, which will then populate up there and give you prices and lead times on the items. Or, of course, sending it to your fellow motion product specialist, and we can get those prices to you ASAP from our inside sales team. Other than that, thank you for coming along this journey on sizing a Festo electric servo application, and I look forward to seeing you in the next one.